Okay, this is the second part. So we now have the data prepared and we check out if the spectra makes sense. So I went into the spectra tool and have a look at the visible spectrum. So there are some strange things appearing here, like this artifact. That's at the edge between the two sensors, so that's something which isn't working properly. Also, that one shows an overcorrection of the water vapor. So one would want to interpolate the 940 into the 1130 maybe for this data set. And moreover, but the range of the spectrum, so the reflectance range is reasonable, so we can proceed with that. So I'll return. What I'm going to do, I'll check the interpolation things. So I go to the preferences and see if the 940 is interpolated. So I'll do an interpolation of 940 in the 1130 because it's not reliable enough in these wavelength ranges as seen in the spectrum. But the other 725 and 825 shouldn't be interpolated. So that's updated now for the preferences, and now I can go into the processing. So I'll select image processing. This one has to be overwritten, or as I make a new name to that. That's maybe the show atom, and here I get a variable water vapor which has to be switched off. Also variable visibility doesn't make sense for this low altitude data, and we just proceed with the standard water vapor of 10 or 1 centimeter column. Now about the BRDF or incidence BRDF correction. So this panel pops up. And here we can select various options. The first one is just a pure cosine correction. Usually you'll end up in overcorrections with that one, so we don't use that. The standard method is this kind special purpose method. It's like the modified Minard. It shows quite good results for this situation. Also the last one could be checked, like the statistical empirical or Lambert statistical empirical, because there's still a matter of research which one is the best. It depends on the kind of data you're processing. Now I select the second one. I'll take the default values here, which have proven to be quite reliable, and I'll do a BRDF correction. This means the incidence BRDF, so the terrain depending BRDF is corrected by this panel. This has nothing to do with the observation correction, which is done in the BREF-core module. So here we got the start of the correction, and we can run the whole atmospheric correction now. This will take a while, that's why I'm gonna interrupt after starting the process. Now processing is finished and we can look at the output data. It took 6 minutes now, and this is quite normal for this kind of data. So I quit here and have a look at the output. This is the test, or which one was it? The show. No, that one. And first of all, the terrain correction worked more or less, so the terrain effects are gone if compared to what we had originally. But still in are some shadows, so cast shadows are not corrected by this processing, and this would require special treatment, but usually it's not very reliable. So that's why I wouldn't recommend doing cast shadow